This is me, Piotr Walczyszyn. Probably some of you already know me because I had this pleasure to come to Belarus a couple of times, I think twice. I was invited by Valerie, so I probably met most of you, and we had a chance to chat, and I already did some presentations. So today my presentation is about a very new cool feature that comes with AIR 3, which is called native extensions. This is, I think, really a awaited feature for many developers, not only mobile developers, because many think this is only a feature for mobile development, but no, this is actually a feature that is available for all the platforms, so you can develop native extensions for Windows, Mac, of course, iOS, Android, Playbook, and also TVs. What are the native extensions? So, like the name says, it's almost itself. It's a piece of code that you can extend your application with, and this piece of code you can write in a native language for the platform that you are targeting. So, if you want to build a native extension for let's say Windows, you will use Visual Studio probably, and some of the languages from .NET framework like V.NET or C#, and compile into a DLL, and that DLL you can then invoke from your ActionScript applications, from Flex or Flash applications, which run in AIR runtime. So it's not an extension for Flash, it's an extension for AIR. For other languages, for Mac, you would write your code in C or Objective-C, similarly for iOS, and in case of Android, it would be, of course, Java. So what we will do today, I'll drive you sort of through this process of creating your first native extension. I have a very simple one, and I will tell you step by step how I created that. Okay, so I don't want to show you much slides, but as you can see here, this is just a single slide that I don't want to show anymore. And today, basically, as I said, it's an extension which gives you ability to extend AIR runtime. It comes with some API for ActionScript API. So when you're writing your extension, you will need to write some ActionScript code. Then, of course, a native code which is compiled into a native libraries like DLLs, jars, assemblies, etc. So all that, and that stuff you package into a file which is called ANE, which is Adobe Native Extension. And basically, it's a zip file. It's like a Swift, something like Swift, basically, SWF. Okay, so let's not show too much slides because I don't think it's really interesting. I think what is really interesting for most of you is to see how you can build native extensions yourself. So let's start with Flash Builder, and I have Flash Builder installed as an Eclipse plugin, so I also have the whole Java environment installed, and also for Eclipse I have the Android ADT, Android Development Toolkit, as well installed. It's a plugin which you can get from the Android website, and it's free. You download it with the install package or somewhere here, install new software. But that's something that's Android specific. So if you go to Android developer.android.com, right here, Circle Echo. Okay. This will, you will be able to download it to the ADT from there. Okay, so let me just do one thing, which I think I should have done before. Let me increase the font size that you can see it, because probably you're on the Beamer. So let me just put something like 18 pixels here. So this will be much better visible for you. Okay, so in this case, you can see I have 3 projects in my Eclipse environment. If I could do Objective-C, also debugging and development, I could have a 4th one, let's say for iOS, because the native extension that I'm going to present you today is a native extension for both Android phones or tablets, and also iOS phones or tablets, or iPhone or iPad. The extension is very simple. You will see it's just invoking a function, native function, and getting some feedback in the result. So the first project here I have, it's an Android Java project. And how do you create this one? It's very simple. So if you have ADT, so the environment for Android, the way you go, you can switch to a Java perspective. You go new, and there you have Android project. And here you can create, let's call it new ANI. And create new project in workspace, yes, you can use the other defaults are okay, you can select which build, okay, so this will be a target for this, for my phone, and application name, whatever you give the name, doesn't matter, let's just put something Korea space, some sort of a namespace, finish. So it would create me a new Android project, as you can see, and even it created a new activity, but basically I don't need this activity, so you can even delete that one. But let me switch back to my already developed ANI. So as you can see, the Java source code here has 4 classes. And the one we will start with is the ANI extension. So it's like an entry point. It's the first class that will be called when your extension is created in runtime. And basically, extension is created when the whole runtime starts. So there is a function, interface that comes with AIR SDK, and let me show you where do you get the Java classes from. So whenever you install the AIR SDK, either with Flash Builder or you download it from Adobe website, you unpackage it, you will have, let me go here, SDKs. And okay, one more point here. I'm using Flash Builder 4.6 and also Flex SDK 4.6. These are pre-release versions of Flex and Flash Builder, but they are available for anyone. So if you go to labs.adobe.com, you can sign up for the pre-release there, and you will be accepted. So it's like an open pre-release program. So we accept anyone who signs up, and you will be able to download the Flash Builder 4.6 and also the beta version, or this is like a release candidate version of 4.6 SDK. And it's worth doing it because it already has the AIR 3.1, I think, even SDK, so the upcoming release of AIR. And also the Flash Builder 4.6 has the built-in support for native extensions as well. So if you want to play with native extensions, it's good to download that version. So okay, let me go further. So in the SDK, you will have, I think, a lib folder, and under the lib folder, you will have Android subfolder, and there is a Flash runtime extensions jar. And if you want to build also, you can also build with the native C on Android. So if you use that, you need this this library instead. But if you're building with Java, you'll need this Flash runtime extensions, and this one you can link to your project. So you can go to the project references of your Android native extension project, go to Java build path, and similarly you would do, like you would want to import a swig in case of ActionScript development. This is the same way you do it, and here just add jars and you point wherever this jar is placed. So in my case, it's where the Flash Builder and the SDK is installed, and that's it. So once you add that to your build path, you will be able to use the native extension interfaces and classes in your code. So first thing, as I said, to do is create a native extension. You can give it any name. Like if you're extending, recently I created a native extension for push notifications, which is also open source and it's available on GitHub on my account. And I would call that one a push extension, something like that. And in this case, this is just a simple demo, so it's I called it any extension, and it implements FRE extension. FRE, this is Flash runtime extension, and sort of an abbreviation, and that's it. So this interface comes with 3 functions. First one, create context, dispose, and initialize. So basically, when you start building your first native extension, you don't have to worry about these 2. But the important one, the one that you will have to override and put some code in, is the create context. So this is the function or a method in that case, which creates your extension context, which you will, again, you will have to build it yourself as well in just a second. And what you have to do, you have to create a new instance of that context and just return it. In this case, you can also do one thing, and it happened to me in my this push notifications project, that I had to also create like a public static function on my extension here. So I have the reference to my context anywhere in my code, even if the code is running asynchronously. Because in your native extensions, you can also create threads which can run asynchronously, and if you want to return back some notifications with Flash events, you have to have a reference to the context, because it has a proper function to return the events back to your application. So any context, so your context implementation is good to keep somewhere. And as I said, you could do something like that. You could put public static, let's say, context, FRE context, and context here. And this one could also be, it would be available in your application anywhere. It will be a singlet on this way. So set this one as well, context equals like that, and then you can access this anywhere. But that's just a sort of a side note. So let's see what the implementation of any context looks like. So if I go into any context, in this case, it extends FRE context class. Okay, it's not an interface, it's a class here. And again, you don't have to worry about this pose, but you can check it out. What you have to override here is get functions method. What it is, it's a special function that returns a map of all your publicly available functions to your ActionScript code, which will be implemented in your extension. So you create new map, which has first a key of string and type of FR3 function. The string is the name, so this is the name of the function that will be publicly available, and it maps to the instance of a free function. So this is my implementation, and also there is a second one, is supported. It's again an instance of is supported function, and we'll look in those two in just a second. And once you create this functions map, you just return it. And then the native extensions mechanism will know that these two functions are available for the ActionScript code, and whenever there is a request, they will be properly mapped into those two implementations. So let's first look at the isSupported function. IsSupported function is sort of like a good practice, because whenever you're building a native extensions, you have to remember that they should probably target as many devices or target as many operating systems as possible. But in some cases, some operating systems may not be available, or on some devices, let's say, some capabilities may not be available. So let's say you want to build a native extension for Compass. And not all the phones, either with Android and previous versions also of iOS, devices did not have the compass sensor inside. So what you would have to do in that function, you would have to check if that sensor is available and properly return a value either true or false, is it supported or not. So basically the developer that is using your native extension or yourself have a possibility to check and maybe react responsibly, disable some features of your application or yeah, whatever which you want to do. And in this case, any function is the function that I will be just calling as a demo here. Okay, so let's jump into the is supported function. And in this case, is supported function is again my function that I implemented, and it has to implement pre-function interface. And the pre-function interface has one method to override, which is called call. And what it does, the call brings you two arguments. The first one is the context in which this call was done to your native extension. So this is this will be actually any context implementation in my case, and it also passes an array of arguments that were passed to this call. So these are actually in this case, is supported function arguments. It can be 0 length, or it can be as many as you wish, let's say, arguments to pass to your native function. In the native function, what I'm doing here, I'm actually constructing a result, which will be a Boolean value, which will return, in this case, it will always return true. And it's basically this line of code that does that, and there is a built-in helper class called FRE object. And FRE object, let's see what it has available here for us. It has a couple of new object method implementations, which allow you to create like new object from Boolean, new object from double value, from int value, from string, and they will properly map to ActionScript types on ActionScript side. And also, if you want to construct a complex object structure, you can do it with this last method here. So this first string is actually the class type that you want to construct. And also it has the second parameter, which are the arguments that you want to pass to the constructor of this class type to construct the instance of it. And later on, with the free object, which is returned, actually, you can also set properties of that custom data model or of your ActionScript code. In this case, it's very, very simple. What I just do, I just return a new object, which is a Boolean value, and on ActionScript side, I'll just get as a result true, a Boolean true value. Okay, so that was a simple call to is supported function. Now the second function is the AE function, and let's see what it does. So again, it implements the FRE function interface. Again, we get a context, and we also receive all the arguments passed to our method here. And what I do, first of all, I check if my argument here is greater than 0. So I'm checking if anything was passed to me to that function. If there was something passed, what I'm just doing, I'm getting the FRE object. And I want to read a property. It's a basically on ActionScript side. I will just show you in a second. what I'm passing to that function, but it's just a dynamic object, ActionScript object. But it could be a static, it could be a static type, but in this case it will be a dynamic object, in which will have a dynamic property called prop. And what I'm just doing here, I'm getting the prop and the string value of the prop, and I'm just logging it to the console. And I'll show you that in the log cut in the second when I run this native extension. And next, what I'm doing, I'm constructing a string result, hello from any, which I'll receive back synchronously from the call to this function, and it just returns it as a result here. Okay, so once I created this native side of my extension, I can go in and start building the ActionScript wrapper for my native code. So I have here, I call it any API, and let's go to the Flash perspective. So in any API, let me call here. It's just this is a standard Flex library project. Nothing special, just standard Flex stuff. And I created a com.ria space any, and I created a simple ActionScript class called any. In that any ActionScript class, let's go first to is supported function, because it's a static function. What happens here, so first I check if my context was initialized. If not, I call the init function. And in the init function, what I do, I create a new instance of the context, extension context, and there is when you create a Flex library project and you also add the AIR SDK libraries into it, in the wizard in Flash Builder has this by default, the checkbox there you can select, and it gives you an extension context class. And this extension context class allows you to invoke the create extension context function, where you pass as a first argument, you pass an ID of the extension that you want to create. And I will show you in just a second where do you assign the ID, but hold on with that. Also, there is a second parameter, and it's called, let me remind myself, context type. This could be a string which you can pass, and it will be passed to your any extension, and this is here. It should be context type, not ID. So you receive it here, and based on maybe that string, you could actually create a different instance. You could have different implementation for different contexts based on some parameters, and this could be this parameter which could construct a different implementation. But in my case, it's just a single implementation, so I'm not using this context type. So in this case, I can pass null here. Next thing, you may wonder what's happening here. Unfortunately, I didn't have enough time to implement also the asynchronous and eventing mechanism to show you today. But basically, the way you can do it by listening on the context. You can listen to a status event, and from the native code, you can dispatch the status event. So yeah. This and generate a handler. So if I receive the status, I need to do whatever on my ActionScript side, and this can be asynchronous, running something running in the background, and then from here I can start dispatching a standard. If I had of course, event dispatcher implementation here, I can start dispatching native ActionScript events later on, but let's keep it. Let's leave it for later. Okay, so once I create the extension context, and I have an instance of it. In this case, it's a static function which is supported. I can call a function called is supported, and this is what I was mapping in the A component. So you just pass a parameter with is supported. If you want to pass some arguments to the function you're calling, you could put those parameters here, like this, whatever. We'll see that in just a second. So yeah, here it is. So this is my second function, which I called any. And this any calls my extension context, call function on it, calls any function, which is the native implementation, and passes an object as to this ActionScript wrapper here, and whatever is returned synchronously from that call to the native function returns as a string, so casts that to the string and returns it back. I'll show you in a second when I will use this. So, very simple implementation. As you can see, for more advanced stuff, as I said, you could also do like extends, event dispatcher, of course, and like start dispatching based on some events passed from the native code. You could start passing some native also or ActionScript events from here, so like dispatch, whatever event, but yeah, we don't have anything to dispatch right now. All right, so let's see, because I mentioned that you have to assign an ID to your native extension, and based on that ID, which you pass here to create extension context, it knows which library to basically instantiate and which one to invoke. How do you do it? There is a new XML sort of a descriptor that you can create now. You can put that in the source of your native extension, like I did here, and it's called like extension XML. It has to have this namespace you give, and here's the ID that you give to your native extension. And you can assign some version number, and then you can start defining what platforms you want to support. So in my case, I want to support iPhone, and also I want to support Android ARM. And what you said, let's say in Android case, you specify what is the jar file that will be necessary when we will be packaging that called native extension in just a second. And so you pass the path to the jar file, and also you specify the class, which is the class that initializes the native extension, and also what is the class that finalizes the native extension. In my case, it's the same class. It could be two separate classes. They could have their different logic based on your requirements. And a native extension then it calls properly when it initializes initialize function, and when it disposes invokes dispose function. And here you should probably do some sort of a cleanup. So it will be probably in this case good practice to clean up my context and just set a null value to it, like that. Okay, the second one is iPhone ARM. So this is all the iOS. That's the way that it's named, but it's the same. There is no separate tag for iPad. It's just iPhone is for all the iOS platforms. And here you specify your assembly with your library. Again, the path to your assembly, and also what is the function that initializes and finalizes your native extension. I'll show you in a second in the Xcode the way it works on the Objective-C side. Next, if you have the descriptor like I do here, you can start packaging it. Now we don't have sort of a tool support for packaging your native extensions, but we have, as I said, we don't. Sorry, this one. We don't have a built-in tool, a visual tool. What you have to do, you have to use the you have to use command line. And there is of course ADT. So here's my command line. I'll show you this quickly. So I created this simple script, but you could do the same stuff as I said with command line. First thing I'm doing in this first line, I'm actually unzipping the swig. So my library, my Flex library here was compiled into a bin folder, and any API swig was created. I'm unzipping it, and actually I'm unzipping it from that only a library swig, because as you know, swig is a zip file which contains a SWF Swift file of your implementation. So I'm just unzipping that single file and excluding catalog XML. I don't need that descriptors, so that's why I have X here. Because I will need what's inside of this swig to build my native extension. And then once I unzip the swig, I can use ADT. So this is the command line package tool for AIR applications. And then you have a couple of arguments that you can pass. So you specify that you want package, you specify a target, it's AE. So in this case, it's Adobe Native Extension. Then you specify what's the name of the AD. So what's the name of the file that you want to package the native extension into. Next, you have to specify the path to the extension XML. So this is the descriptor that has the ID and the different sort of metadata for different platforms. And then you have to specify where's this SWC file, Swift file for that native compiled file for that native extension. And then you have to start specifying different platforms for your native extension. So first one is a default. So if you're doing that's another point I didn't mention here in extension XML, I have something a platform called default. So if it's a default platform, it's any. So you can specify that can be for any platform. Basically, it's good to put that when you're doing a debugging in your code, so you can run the application in ADL on your desktop. Although native extension will not run in ADL, that they will break. So that's why it's also sometimes good to in the is supported maybe function check if you're really running on that OS, which you should be running, and also return proper value. But yeah, as I said, this is just the default platform. You could omit that if you don't want to do debugging. If you don't want to run the app on the local on your local environment, then you can omit that. Next one is important. Next one, I specify platform, which I specified the Android ARM, and here is the path to a library Swift SWF file, which was unzipped from this any API Swift. This is a little bit tricky because what you can do, you could have a different implementations per platform built into a different SWF files. So you could have a different, let's say, Swift file for implementation for iOS, different for Android or any other platforms. In my case, it's the same code because it's a simple native extension. So I have just one library Swift, which is unzipped from this API Swift. And then the second parameter here is the AD Android jar. So this is the jar that contains my Android project. And let me show you how you can export the jar. So once you build it, it's very simple. Now once you build your Android stuff and your Android code, you just can right-click on your project, you go to export, you just select jar. You can include whatever it's in your project, or you could probably exclude most of the stuff, just include the generated stuff and the source. Select that you want to include the class files and the path where it should be packaged into finish. Yes, override. Jar creation failed. Okay, I think I have to just refresh this project. Some weird Eclipse bug, I guess. export again. Let's leave everything. It's okay. Overwrite. Yes. There we go. So what it does, it generates a jar file from your project, and I pointed it to build it and copy it to my any API project, so I can see it here. Any info jar. It's available here in the root of my project, as well the script, and also iOS version, which I'll show you in just a second. Okay, so here, Android jar, platform, iPhone ARM library. So for iPhone, the same procedure, platform iPhone ARM, library Swift, and the path to your assembly from the from Xcode. Next one is just I copy the file from this project to the next project, which in my case is any example, and I clean up the library Swift, which was unzipped, and that's it. Now, the third one, the third project is any example. In the any example is just, in this case, a standard Flex mobile project. Nothing special here, except if I go to the properties, and I want to remind you that I'm using Flash Builder 4.6, which is the pre-release version. Here you have Flex build path, and here you have something called native extensions, a new tab which was not available before. And here you can add any, so you can point to the any wherever it will be compiled. So in my case, it's here, example, any API, here we go, and I can point it to this one. And also there is a checkbox asking you if you want to update the AIR application descriptor. I'll show you why this is important. So, in just a second. So, if you include that, you're ready to go. You can start building and deploying your application. So this move here, adding a native extension library to your build path, results in that you can start using your ActionScript code, which you created in any API project, like you would use any other library in your ActionScript project. So as you can see here, I have a variable here called any, which has which is of type any, which is called real space any here, and my very simple Flex project looks like this. Let me show you the design view, and in just a second I'll switch to my camera view. It has a single button is supported, which I will press. It will invoke native code, which will return true, because in my case it always returns true. And if it returns true, it will enable this call any button, and then I can call any button, so press that one, and it will output some string value returned from my any. So maybe let's jump into my phone. So let me build that one and deploy, and let's look at the view here. Right. Come on. Oh, there we go. Everything okay, connected to the debugger. I think the contrast is, you know what, hold on a second. I'll try to turn on the light, and maybe the contrast, oh, yeah, now it's much better. So, as I said, so if I press this supported button, it returns. So, as you can see, it has enabled the call any button, and also it has printed out true. This is the result which was sent back. Also, what I wanted to show you, because I have the ADT on my Eclipse installed, I could connect to a log path of my phone, and I created a log category called 80, which prints out actually whatever is printed out on the log card of my Android phone. So now if I press call 80, you can see, first of all, it has printed out here an any function call on the console here, and hello any, this is the string that I passed in my dynamic object in a property. And also, unfortunately, my camera contrast is not very good here. Okay, but it also, trust me, it has printed out hello from any, a string here, which is the value passed from my native code. So if I go back here, I can show you. Let's see here. Let's remind you what I was doing. What code was there? So this was any function here, and any function was. Okay, so it returns the hello from any, and it also logs to the console. So this is the line here. It logs a value sent as a property of a dynamic object passed to my native extension. And on the Flex side here, or ActionScript side, doesn't matter. If I switch back to the code view, you can see what I'm here doing. Basically, in the here it is.